Hey guys, it's Mr. Hing here. Welcome back. I hope you are all so well. I think it's Kunjani. Okay, so let's get started. Today, what we're doing is probability again. However, we are doing just examples of how to draw tree diagrams. So we can basically call it probability of tree diagrams part 2. Okay, I'm not sure how many parts I'm going to make, but I just want to give you another option of how to solve probability questions regarding tree diagrams, and as well as I'm going to go over again how to draw tree diagrams. Okay, so why don't we jump right in? So let's have a look at the question. The question is saying, draw a tree diagram of a person going to a restaurant and ordering a main course meal of either lamb, pork, or chicken. Okay, and then he chooses, and then choosing a dessert option of either malva pudding, or ice cream. Ah, okay. Let's have a look and see. All right. So remember what I said in the previous video. So by the way, I've made a video already on probability of how to draw tree diagrams. If you want to have a look at it, it is in the playlist of Maths Lit. So let's have a look at how we're going to draw this one. So I'm just going to zoom in a bit. Okay, so let's have a look. So they said that there was a main course of lamb, pork, and chicken. So this is our first event. This yellow line here, please, you do not need to draw this in your test, in your answer sheet, but I'm just drawing it to show you the separation between the first event or situation, which was having a main course, and then the second event or second situation, which is having a dessert. So what you would have needed to do is you would have drawn, remember our first event, there are three possibilities. So it is lamb, pork, or a chicken main course. Okay, so that is why we draw three. So it's lamb, pork, and a chicken main course. Okay, and then directly from this little spot over here, directly after the main course, we will draw as many lines as there are possibilities for a dessert. So how many possibilities are there for dessert? There's two. One is malva pudding and the other possibility is ice cream. So it's going to be two lines. One line for malva pudding as a possibility and then one line for ice cream. And then you do that the same for pork, because if you choose pork first as a main course, then there's a possibility of malva and ice cream. And then if you choose chicken, then there is a possibility of malva and ice cream. So as you can see, guys, this is a tree diagram laying out all the different possibilities a person would choose a main course and a dessert at random. Okay, why don't we have a look at answering the question? So this is asking for the probability, question one, of having a lamb and then choosing ice cream. So what I wanted to highlight to you guys is this is another way of answering questions from a tree diagram. So as we can see, let's quickly list the total amount of all the possibilities from this tree diagram. So if we choose lamb and malva, that's our possibility number one. Then lamb and ice cream, possibility number two. Pork and malva, possibility number three. Pork and ice cream, four. And then the same chicken malva is five. Chicken ice cream is six. So can you see there is a total of six possible outcomes, right? So look how beautiful this is, right? Instead of doing all that addition and multiplication, this is another way of doing probability with a tree diagram. So it's asking for probability and then ice cream. So this is the other way. Right, you would take your finger or your pencil and you would say, you would draw from this point, or not draw, you would just trace from this point. My first possibility was lamb. So you would go to lamb. Then we are at lamb, and then we want to see the possibility of ice cream. So we would go along here and go to ice cream. So this is the one possibility that we want. We want lamb, then ice cream. So it is only one possibility that is we want out of a total of 6 possibilities. So our answer can simply be, remember what did I say? When we are doing probability as a fraction, we write the favorable outcomes on the top, which is one favorable outcome, lamb then ice cream, over the total amount of outcomes possible, which was 6. So that is as simple as it gets, guys, if you want to do it this way. Okay, so it's 1 out of 6 chances that a person will choose a lamb, then an ice cream dessert at random. Question number 2 is saying chicken and ice cream or chicken and malva. So let's go ahead and do that. So firstly, it is chicken and ice cream. Let's note that down. So chicken, then ice cream. That is, we just want to know that that is the first outcome that we want. Or it is chicken and malva. So that's the other option. So we have 2 favorable outcomes in this instance here. So it's going to be 2 favorable outcomes out of a total of 1, 2, 3, 4, 5, 6. So our answer is going to be 2 favorable outcomes out of a total of 6. And remember, we always need to write the answer in its simplest form. So that is as simple as that gets. Then lastly, the question 3 is probability of any main course with a malva pudding. So let's go ahead. So any main course. So let's go lamb and malva. That is what we want. Lamb and ice cream. We do not want that. Okay. Then, sorry, I didn't take all these ticks away from the previous question. Okay. So then pork and malva. I do want that. We note that down. So it's 1. We have 2 favorable outcomes at the moment. Pork and ice cream. We don't want. Chicken and malva, there we go. And then chicken and ice cream, we don't want. So for this question, our total favorable or desired outcomes is 1, 2, 3. So it's 3 desired outcomes out of a total of 1, 2, 3, 4, 5, 6. 6. And that simplified is a half. So guys, that would be the probability. The P stands for probability. So this would be the probability of any main course with a malva pudding dessert chosen at random. Okay, so that is another way and a nice easy way of how to get the answer of your probability. Let's have a look at the final and second example. So the example is draw a tree diagram of a person rolling a dice, that's event number 1, and then flipping a coin to show all of its possible outcomes. So let's do that again. So what I did here in red is I just showed you the uh, that to split the 2 different situations or events, but you don't need to do that in your test once again. So rolling a dice, how many outcomes? 1, 2, 3, 4, 5, 6. Then from each of these outcomes, we do what? We flip a coin. So if we roll a 1, then we flip a coin so we can get heads, tails, and then so on. Roll a 2, get heads and tails. So in total, by the way, this would get you full marks just like that. And then just to make it easier, we know that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 total outcomes for these 2 events happening together. So question 1 is saying, what is the probability of getting an even number and then a head? So it has to be a heads after even number. So let's try that. Is 1 an even number? No, so that's not a possibility or desired outcome. 2 and a heads? Yes, we want that one. 2 and a tails? We don't want tails. So 3, we don't want 3 at all, so we're not going to consider that. 4 is a even number, and then a heads, we want that one, but we don't want tails, so we're not going to consider that. 5 is an odd number, we don't want that at all. And then 6 is an even number, and a heads, we want that. 6 and a tails, we do not want that. So there you have it. We have our 3 identified desired outcomes. So it's going to be a possibility of 3 desired outcomes out of a total 1, 2, 3, 4, 5, all the way to 12 possible outcomes. So it'll be 3 over 12. Don't forget to simplify. You divide that by, or you just put in your calculator, and it will become 1 over 4. Okay, and that is our final answer. Okay, guys, let's go on to question 2. Question 2 is saying, what's the probability of at least one tails being happening in both events? Happening. So let's go along. It doesn't matter on the number that you get. So 1 and heads we do not want. Sorry, let me just erase these ticks because we don't want them for this question. Okay, so let's get started. 1 and heads we don't want. A 1 and a tails, yep, we want that. 2 and a heads, don't want. 2 and a tails, yep. 3 and heads, no. 3 and tails, yes. 4 and heads, no. 4 and tails, yes. 5 and heads, no. 5 and tails, yes. 6 and heads, no. 6 and tails, yes. So we want 1, 2, 3, 4, 5, 6 desired outcomes, right? 6, the probability will be 6 desired outcomes out of a total of 12. And therefore, our probability of rolling at least, or sorry, flipping at least one tails, no matter what we roll, is going to be a half chance, or the half chance we will get tails. Okay, and then lastly, question number 3, what is the probability of rolling a 3? So it has to be a 3, guys, and then a heads or tails. So let's have a look at this. So we can go 1, we do, let's just erase this. Remember, guys, we only want a 3. We do not want any other number. Okay, so let's have a look. So 1 we don't want to, none of those numbers, just the 3. So we'll go 3 and heads we want, and then it says 3 and a heads or tails, so we can get a 3 and a tails as well. So we have 2 desirable outcomes, so our chances are 2 out of 12 chances, so that will equal total of simplify that will become 1 over 6 chances that we will get 3 and then a heads or tails. Okay, guys, so that brings me to the end of the lesson. Yeah, I think this was a good one. Please comment questions if you have any. If you would also like any other videos that will assist you, please do comment in the section below. If it was helpful, like, share, subscribe, share with your friends so that they can get the marks they want to. So with all of that being said, from me to you, bye.